Now we come to the slow rebirth of Europe. Europe gradually emerged from its dark ages. The warring clans, the small fiefdoms, the plague, the Black Death, low standard of living, feudal circumstances was a pretty miserable time for Europe for a long period. Europe did, however, recover. Through the Dark Ages, there were glimmers of change in astronomy, especially some diffusion of the ideas from the Islamic Empire. Spain had a tradition of learning long before the arrival of Islam, and so Spain served as the bridge between the Islamic Empire and the Renaissance. Isidore of Seville, drawing on Roman texts, wrote on atomism and cosmology in the 7th century. These were still Greek ideas and second-hand and not really much original new material, but they were subject to lively scholarly debate. Abd al-Rahma in the 10th century formed the Caliphate of Cordoba, and this is possibly the highest flowering of the Golden Age of Islam. His son sent agents throughout the world to bring back texts. Cordoba and later Toledo became centers of learning in all the sciences, and not just learning. Soon, original and new work was being developed too. An important innovation was the use of Indo-Arabic numerals, the ones we use. Slowly, they gained acceptance for scientific work. Remember that Roman numerals, an extremely clumsy system, and part of the reason the Romans weren't good at science, Roman numerals remained widely used in trade throughout Europe until the 16th century. Another thing that happens around this time is the rise of the university. The university is a European invention, evolving from Christian, monastic, or cathedral schools associated with the great cathedrals of the early medieval and even the Dark Ages times. The university was developed to satisfy an increasing demand for clergy in growing urban populations. Clergy were supported by their churches, and they had the luxury of taking time to learn. And so these were scholastic situations. The first universities in the world were at Bologna in 1088, Oxford in 1190, and in Paris in the early 12th century. I visited the University of Bologna, and in the central courtyard of its oldest building, you can see the family crests on the ceiling of some of the scholars that studied there in the 12th and 13th century. Extraordinarily, some of them came from Africa and South America. The idea of traveling across the world to study at a university in the 13th or 12th century is truly amazing. But these places were magnets for learning. They were scholastic guilds, and they sought recognition, sponsorship, and some wealth from the secular powers of their states. Pope Gregory IX in 1233 made a dictum that any official teacher from the university at Toulouse could teach anywhere, and so immediately we have a set of teachers who can travel around Europe. The curriculum was quite simple in these days. It consisted simply of 7 subjects. There was the trivium, grammar, rhetoric, and logic, and the quadrivium, arithmetic, harmony or music, geometry, and astronomy. So astronomy was one of the 7 core subjects of the curriculum of all universities, right from the beginning. And astronomy, of course, is a close cousin of geometry and arithmetic, on which it depends. The first professional schools at universities were in medicine, law, and theology. Much of the new learning arrived from Spain. The Crusades, beginning in 1095, brought Europeans in contact with the Eastern Islamic scholarship. This scholasticism, which was some strange combination of Aristotle and Christian dogma, was able to point out inconsistencies in the ancient astronomy, in the debates, for example, between the ideas of Aristotle and the ideas of Ptolemy. And so here we have the first view of the liberal arts from the foundation of a university 1,000 years ago. Here's where the medieval universities of this world were. You can see them distributed mostly in Spain and Italy, with a few in Germany, France, and England. What we have at this time is a Christian cosmology, because the dominance of the Catholic Church leads to a cosmology which has to incorporate the religion of the time. The pivotal figure from the 13th century is Thomas Aquinas, an Italian Dominican friar, later sainted. He wrote a book called Summa Theologica, which is the fundamental reasoning behind Christian theology. He made cosmological arguments for the existence of God, and so he managed in his mind to reconcile Aristotle with Christian theology. This very influential work cemented a cosmology of Aristotle which was centered on the earth. The earth was immobile, and the heavens clearly reflected God's glory, and the earth, as the pinnacle of creation, was mirrored by humans, the pinnacle of God's creation. And so Aristotle becomes a part of the Christian dogma, and astronomy is co-opted to be part of theology. We'll see an echo of this much later in Galileo's downfall. Here's a view of the universe from this time, the Christian theology of Ptolemaic system co-opted by Christianity. Here we see it mapping into literature in the Divine Comedy of Dante Alighieri from 1320, where on the right he draws the topography and geography of heaven and hell. However, there were some radical Christians, so even within the constraints of Christian theology, some Christians were having extraordinary and interesting ideas. Nicole Oresme, from the late 14th century, taught at Paris University, and in a book he said the earth can move without leaving the air behind. The arrow fired in the air inherits impetus from the archer, and so the earth could move in circles about the center of the universe, and the earth rotating can clearly explain the apparent motion of stars. So right here he is completely rebutting Aristotle and moving strongly away from a geocentric, immobile earth cosmology. We also have Nicholas of Cusa, who talked about the relationship between God and man, and talked about the natural state of the universe being change. He concluded in his work that there should be no center to the universe, no fixed place, and also that the universe should have no edge, and so must be infinite. Again, these are quite radical ideas for the time. We should recognize a larger cultural context for the science and the theology. Remember that natural science did not exist in and of its own right. Most of the scholars were working in monastic settings. The universities were heavily beholden to the church for their power, influence, and money. And natural science was almost totally subservient to Christian theology. In the world at that time, there was a static social and political order that mirrored the static hierarchy of the heavens. And it was embodied in an idea called the chain of being. You can see in documents from this time the chain of being that defined essentially all living creatures on the earth, from the humblest worm to elephants and dogs, in an order, a hierarchy, where the oak was nobler than the bramble, and the horse was nobler than the dog. Everything had its place in the chain of being. What was important about this was that it's a deeply conservative worldview. However you were born, into poverty or aristocracy, was the way you would die. There was no social mobility, no hope of movement. And in fact, this conservative worldview, mapped into the social order, was reflected in the heavens too. And it was a resistance to motion or dynamism that was squashing natural philosophy and science at the time. Another innovation that was really important for opening up science at the end of the dark times was printing. Techniques for printing had been invented in China and used in medieval Europe for a long time. There was movable type going back almost to 1000. But Johannes Gutenberg perfected technologies for the efficient reproduction of texts. He had mechanical movable type made of metal. He had a mass production method and a way of producing type from alloys, where it made it very sturdy. He used oil-based permanent inks. He had a press that was superior to any before, and he invented the first Latin typefaces. Gutenberg's innovations led to an explosion in the diffusion of knowledge, from being things that were incredibly rare, where no common person would have even one, and where it took a single person a year to write or transcribe a book. Books now were cheap, and they could suddenly be owned by almost anyone. And so we get to the Renaissance. The Renaissance, which means rebirth, actually began in the late 14th century in Florence, Italy, and lasted 200 years. We know it as the flowering of art and culture that had its roots in the rediscovery of classical Greek philosophy. In art, it manifested in the use of perspective and a realistic treatment of nature. But we can see a clear analogy and mirroring to how science might benefit from this rebirth. Because in art, if you consider the difference between the early medieval mosaic on the left and the high Renaissance painting by Perugino on the right, separated by a few hundred years, the use of perspective is a dramatic thing in art. It's essentially a loosening of the rigid God's eye view of the world and an embrace of a naturalistic and humanistic vision. Renaissance art was marked by this increased appreciation for natural world. Artists applied mathematical rules of perspective, which added dynamism to their work. They were using the tools of the scientist. Their subjects were no longer exclusively religious, even if they mostly still appeared in churches or religious settings. They were pushing the envelope of what was possible with art. And of course, embodied in Leonardo, we have the complete synthesis of art and science. On the left, a medieval woodcut showing what Aristotle said the motion of a cannonball would be, according to his physics. On the right, we have a drawing by Leonardo of a cannonball as it actually is, obeying a parabolic trajectory through space. The artist sees the science very clearly. Leonardo also dissected cadavers to more realistically render anatomy and make himself an even better sculptor and artist. And that's the end of this topic.